right, good morning everyone, and welcome back to another exciting day in mathematics. How's everybody doing? Good? Alright, so warm-up number 54 is on the screen, and it reads number 1, solve and allow for imaginary numbers, 3x squared plus 27 equals y. Number 2, it says graph, f of x equals x squared without a table. Then write a rule and graph the transformation if g of x equals af 1 over bx minus h plus k, given the parameters a equals 1, b equals 1, h equals 3, and k equals -4. Number 3 says, solve by completing the square, x squared minus 8x minus 10 equals y. And for number 4, they give us a circuit, and they want us to compute the voltage of the capacitor. And in the circuit, we have, give me a second. On the circuit they give us, at the top they have 2 ohms, then another component 3 ohms, then 1 ohm. On the right side 3 ohms, and in the center we have 3 ohms. And the given current is 24 plus 12I in amps. So I'll give you some time for that. Get started please. Copy that and go. Yeah. Go in for your initial position, but work your way up as fast as you can. As you can, remember, not going fast, but as fast as you can. Some of you it's going to take a little longer, but some other people it's going to take a little bit less. So, All right, here we go. Number 1. Turn to your neighbor, let them know what you got for number 1. They should be done with that one, hopefully. Alright, so hopefully on this one, out of the 5 methods, which is the method easiest to use for this one? Square roots, yes? So we set it equal to 0, 3x squared plus 27 equal to 0. Oh, let it go. There it is. Alright, and then from there we subtract 27 to each side. Subtract 27, subtract 27. So we end up with 3x squared equals to -27. And then we divide by 3, divide by 3. We end up with x squared equals to -9. And last but not least, take the square root from each side. So we end up with x equals plus minus 3i. That is correct. That negative square root is an imaginary. Okay? Alright, let's go to number 2. Number 2 by now should be a piece of cake, yes? Yes, Mr. Q. Alright, so if I was to graph the original function, which is x squared, let me do that here. My original function always goes through the vertex 0, 0. So, there it is. This is f of x. What's the vertex again? 0, 0. So I'm going to move that one according to the parameters that they give me, which is 1 of a, 1 of b, and then we got 3 of h and -4 of k. So this becomes g of x, f of x minus 3 squared minus 4. So according to this, where would my vertex be now, according to that movement? Tell your neighbor, what would be my vertex, my new vertex? Alright, my vertex, Bree, what's our vertex? Very close. So what number did we substitute in here for h, guys? 3. And here for k, -4. So therefore, at 1, 2, 3 to the right, 1, 2, 3, 4 down. So my new vertex would be down here. And this is my g of x. Since A is 1 and B is 1, there's no compression or stretches, either vertical or horizontal. Yes?
Yes, execute.
All right, good. All right. Let's go to number 3. Now, we've been doing these already for a while. Completing the square, yes? So I'm going to go through the process just to make sure we got the process down. So first things first, set it equal to 0, yes? Next, divide by the leading coefficient. What's my leading coefficient? Divide by 1, and it stays the same. And if you noticed last week, we weren't doing that step, but just for the sake of going through the process, because we're going to need it today. Next, we need to eliminate the constant, so I add 10. We end up with x squared minus 8x equals to 10. We need to complete the square here, so what do? Yeah, negative 8 over 2 squared to both sides. Negative 8 over 2 squared to both sides. So x squared minus 8x plus 16 equals to 10 plus 16. What is 10 plus 16? 26. Bring everything else down. So far so good, yes? Next, how do I factor this with a shortcut? Yeah, take the square root of the first, square root of the last, sine of the middle, and write that squared. From there we solve for x. That means we need to get rid of this squared, so I take the square root. Whatever I do to one side, I do to the other. I'm left with x minus 4 equals plus minus. I'm going to leave it as a radical for right now. I don't want to get into the decimals yet. And then I need to leave x by itself, so that means I need to add 4 to each side. So x equals 4 plus minus square root of 26. This is my answers, or these are my answers. What are my answers? X equals what? 4 plus square root of 26, or 4 minus square root of 26. Now, just FYI, these are real numbers, yes? The only thing, they're decimals or estimate. All right, let's go to number 4. The last one, your favorite. Remember this one? Yes? Here we go. They want us to find the voltage. So without looking at your notes, tell your neighbor the formula for the voltage. How do you find the voltage? Good job, everyone. I heard V equals I for current times Z for impedance. Yes? You're like, oh, I remember now. Okay, so the voltage is the current times the impedance. So what is a current? Current is 24 plus 12I times the impedance. Let's see, what are they talking about? The capacitor. So what is our capacitor according to that circuit? 3 and 2, so that's how many? 5, and it's an imaginary, and it's a negative, so it's negative 5I. You guys remember these, yes? Oh, yes. So 24 times negative 5, that's negative 120I. 12I times negative 5I, that's negative 60I squared. Am I done? No. Negative 14I squared. So what is negative 1 times negative 60? That's positive 60. Bring down the negative 120I. And this is the voltage going through the capacitor in amps, yes? Are we doing yes? All right. So, agenda for today. Warm-up number 54 we just finished. Today we're still working on complex numbers, although we're going to approach it through the lens of quadratic equations. And then tonight's home play is pages 146, 147. and they're going to be exactly what we covered today. So make sure you're taking copious notes, you stay focused. If you need to revisit the lesson, make sure you go to the YouTube channel. If you're absent, if you're watching online, make sure you go to Nearpod to get the pages or to your textbook. But I'm going to give you the Nearpod code right now. Here's the Nearpod code. Nearpod code RBM6F, RBM6F. In there you're going to find the play sheets, yes, for the home play. Alright. And last night's home play, or last weekend, just to make sure that I'm making emphasis, tell your neighbor why that's so important. Yeah, because all we got left, guys, for this month, we have just this week and a couple more days when we come back, and November's gone. After this week, we're on vacation for Thanksgiving. You're like, yes. What? What? I'm thinking like, Thanksgiving break, tamales, let's go. Right? Yeah, that's true. Okay, then turkey. You ate tamales on Christmas? Not on Thanksgiving? Oh, we eat tamales all the time. So. Whenever they're available. So yeah, guys, I'm telling you, once we come back, we're going to have our semester final, including I'm going to be checking your binders to make sure that you have all that. So that's 50% of your grade, the notebook, binders, and your semester final, which is only a 3-day. I'm trying to cut it short. Instead of 4-day, I'm making it a 3-day. Is that okay? Yay, by the way. All right, get a Cornell note ready, please. You don't need a fair model. And could I get the last person on each row, go get a graph paper for your row, please. 1 per person. So our objective for today, I can identify complex solutions to quadratic equations. And like I said, we're still on complex numbers, but we're going to be looking at it through the lens of quadratic equations. Okay. So today's going to be a fun approach. Just stay focused and stay on task because it's going to go pretty quick. Thank you, Mr. Q. You're welcome. So for your Cornell note, yes. For your Cornell notes, write your objective at the bottom left. You don't need a Ferrer model because we already know what complex numbers are. Is that correct? Say that again. Oh yeah. It's always been there. Yeah. You guys never noticed this? The I read, we read, you read? Yeah. Yeah? Yeah. Yes. Yeah. All right. So with that said, so our concept for today is still what? Complex numbers. Do we need a Ferrer model? No. So you know the definition for complex numbers. Oh, what is a complex number? A complex number has what, Lenny? 1 real and 1 imaginary. Simple. Is that what you tell your neighbor? Yes? Bam, and this is what they look like. Yes? Yes, Mr. Q, we got this. Okay. So, today we're going to be talking about more of that, since they're going to come up pretty often. So, with that said, I'm going to be talking about real solutions of quadratic equations and non-real solutions. So, on your Cornell notes, I want you to write this down in blue. I want you to write real solutions. And right next to that in red, I want you to write non-real solutions. And in parentheses, just write square root of a negative. Square root of a negative. Okay? So I'm going to give you how it looks once you finish solving a quadratic equation at the end, what a real solution looks like. Ready? Here it goes. Let me give you the first one. X equals plus minus 3. Tell your neighbor the two solutions for that one. Yeah, positive 3 and negative 3, and they're both what kind of numbers? Real numbers. Yes, okay. Next, x equals, how about 5 plus minus 3? Tell your neighbor the two solutions for that one. Two solutions are what? X equals positive 8 and x equals what? 2. Does everybody see it? 5 plus 3 is 8. 5 minus 3 is 2. And these are still what? Real solutions. Next, x equals 5 plus minus square root of 26. Question: are these real solutions? Yes, they are. Why, Mr. Q? Because if they weren't, they would have a negative inside the square root like we did over here in red. Does everybody see that? All right, so these are real solutions. So what would be my two real solutions? X equals to what? 5 plus square root of 26 and 5 minus square root of 26. So these are the possible solutions you're going to get tonight for your homework. Okay? Let's go to non-real. X equals plus minus square root of negative 9. Tell your neighbor the two solutions for that one. Very good. Let's see. X equals what, Jessica? What would be one of the solutions for this one? Natalia, help her out. 3i, that is correct. That's one of them. That means the second one is negative 3i. Yes, that is correct. So how do we know that they're not real, Mr. Q? Well, when there's a square root with a negative number inside. Let's do another one. X equals 5 plus minus square root of negative 16. Tell your neighbor your two non-real solutions for that one. Tell your neighbor. Let's see, Brianna, what's our first solution? Five plus square root of positive 4, what? I. That is correct. That means that our second one is 5 minus 4i. Yes, that is correct. How are we doing? Good? Yes? And so on and so forth. So what do you notice different from the non-real to the real? Non-real have what? I's or negative square root. So make sure you make an emphasis that these are going to have a square root of a negative number inside of the square root. Okay? All right, enough of that easy stuff, shall we? All right, get your graph paper in front of you, please. And turn it to the side where you have the two small size, graphs, and write this down. Example 1. It says graph and state how many real solutions are in y equals 2x squared plus 4x plus 1. Copy that, please. So today's session is going to be a little challenging, but it's fairly easy since we've been doing a lot of the practice on the warm-up in regards to these. So check this out. First things first. I want you to set it equal to 0. Let's do this together. Here we go. Set it equal to 0. So 0 equals 2x squared plus 4x plus 1. Next, let's eliminate the constant. Eliminate the constant, and I'll show you why in a bit. Minus 1 minus 1. We got negative 1 equals, and then we got 2x squared plus 4x. Now, before I do the next step, writing utensils down, look up to the screen. Writing utensils down. All right, here it goes. So, last week I gave you guys plenty of practice with this, and I gave you a system which is y equals 2x plus 3 and y equals x minus 1. You guys remember these? Yes? And I said, to solve this using substitution, I said, in the second equation, instead of writing y, what was y over here first? Y is what? All this, so we would substitute that in there, so it would be 2x plus 3 equals to what? X minus 1. Remember that? Then we would solve and so on and so forth. But what if I said, I'm going to give you this now, and I want you to write a system. So, the system has to be two equations. So what would be my first equation? The one in red equal to y, yes? And the one in black equal to y. That would be my second. I'm going backwards. Does everybody see that? But this is in y notation. So, if I look at this in the same lens, everybody see what I'm doing? I'm going to write a system using this. So watch. F of x equals 2x squared plus 4x. Do you see it? Yes? So for my second equation, I would write what? F of x equals negative 1. But now since it's in function notation, I'm going to use g of x equals negative 1. Copy that, please. Not this. This was just so that you can transition to that. All right, next. It says to graph. So I'm going to start with f of x because we always graph f of x first, yes? Okay. Look at f of x. F of x now is 2x squared plus 4x. So, your life depends on it. Let's say I brought a chopper. Does everybody know what a chopper is? Okay, a helicopter. Those of you that are watching online that don't know what a chopper is. And I got everybody on board, and I dropped you off in the mountain with no bushes to hide, no rocks, no nothing, no technology, no restrooms, and you needed to poop. So to get off the mountain, you need to graph this. F of x equals 2x squared plus 4x. So neighbor, what is the one method that you can use with anything to graph that? Try it with your neighbor. What is the one method to go to? Some of you are like, I already pooped. Alright. The simplest method of all. Doesn't matter what function they give us, and even if we don't know what it looks like, the simplest method is to get a table started, x and f of x, with a domain -2, -1, 0, 1, and 2. Who said that? Some of us, yes? Yeah. All right. So I'm going to use this f of x equals to 2 parentheses squared plus 4 parentheses. To substitute each of these values and get a value for f of x. Okay, here it goes. I'm going to start with negative 2. So if I substitute negative 2 here and here, which I'm not going to do, but we're going to do the star noodle. My first value would be what, negative 2? What is negative 2 squared?
4.
4 times 2? 8. Okay. Plus, what is 4 times negative 2?
8.
Negative 8. So what is 8 minus 8? 0. Okay. Next value is negative 1. So what is negative 1 squared? 1 times 2? 2. And what is negative 1 times 4? Negative 4. So what is 2 minus 4? Negative 2. Yes. Next value, 0. What is 0 squared? Times 2. 4 times 0. 0 plus 0. Yeah. Am I going too fast or you okay? Okay. Next, 1. What is 1 squared? Times 2? 2. What is 4 times 1? 4. 2 plus 4 is 6. And find me that last value by yourself, since you already know how to do the process. What's our last value? Tell your neighbor, please. Last value, please. All right, last value. Brisa. What you get for the last value? Help her out, Alexa. Noor? 16. Hands, have you got that? That is correct. Let's graph that. Negative 2, 0. Negative 1, negative 2. 0, 0. 1, 6. And on mine it doesn't fit, but you should be able to fit 2, 16 on yours, yes? Way up there? 2, 16 somewhere up here?
Never mind.
Okay. There it is. No. All right, and let's label this one f of x. Okay. All right, so we graph f of x. Now let's graph g of x. G of x goes through where? Negative 1. Where's negative 1 of y? Negative 1 is right there. Since it doesn't have a slope, it's a straight line going through that point. And there it is. That is my blue g of x. G of x. Okay. All right, let's practice to make sure, before I answer the question, let's practice here on in your graph. You have space in here so we can use work there. So I want you to write y equals 2x squared plus 4x plus 2. I want you to do that process of writing me the system. Don't graph it yet, just write me the system for this one now. And label g of x in red. Right there where I'm at on the same graph. All right. So first things first, what do we do? Set it equal to 0. What do we do next? Eliminate the constant. So what do I do? Subtract 2. Subtract 2. So I end up with negative 2 equals 2x squared plus 4x. So my system for f of x, we write what? 2x squared plus 4x. And for g of x, what do I write, everyone? Negative 2. Hands if you got that? Okay. So if I was to ask you to graph this, we don't need to do a table again because this is right here. Is that correct? F of x we already have. So we just need to graph that one. So it's going through what value? Negative 2. I'm going to do that in red. There it is. And that's my new g of x. Alright, just for the sake of practice, over here to the right, I want you to write y equals 2x squared plus 4x plus 3. I want you to write me the system for that one, and your g of x will be in green, and I want you to graph that, please. I'll give you some time. Copy and go. Alright, so you should have your system by now, yes? Tell your neighbor that your system for this one right here, please. See what you got. Alright, Lenny, what'd you get? G of x is what? Negative 3, and f of x? Hands, have you got that? That is correct. So if you were to graph f of x, it's already there. And g of x would be through negative 3. And this is my g of x. Okay? So, show me with your fingers how come you're writing a quadratic as a system and graphing it. 4 5s, 4 5s, okay. So now, let me answer the question. Look up to the screen, write your utensils down, you're going to miss it. It says, graph, did we know how to graph these as systems? Yes, okay. So the process is set it equal to 0, eliminate the constant, write your system, do f of x first with a table from negative 2 to 2, and g of x is a linear, there it is, okay. We did that to all of these. But then it says, state how many real solutions. So watch, look what I'm going to do. Don't copy this, just pay attention. I want you to think it out through your, to yourself. Don't say it out loud. For this blue system, here's my f of x, and here's my g of x in blue. That one has 2 real solutions. Next, I'm going to go to this one. F of x is right here, g of x is in red. That one only has 1 real solution. Let me go to the last one. F of x is right here, g of x is down here. This one has none real solutions. So think about this question. How does Mr. Q know that the blue system has 2 real solutions? The red system has 1 real solution, and the green one has none. Talk it over to your neighbor. How do I know what are the real solutions? I think we got it, yes? Yeah, I saw Brisa and Valerie over there. They're like, oh, I got this, Mr. Q. Yes. All right. So, can you elaborate for us, please? How do I know how to identify real solutions? Juliana, what do you think? Yes. So let's write this out underneath, guys. To identify the number, I'm going to put a hashtag, the number of real solutions, we look at what, Juliana? intercept. We look at the times g of x intercepts what, guys? Intercepts f of x. Yes, that is correct. 10 cubed. Let's look at the blue one in case you missed it. Look at the blue one. How many times does it intersect f of x? Twice. The red one only once, and the green one none. That's why there's none real solutions. So what, from 1 to 5, how comfortable are you with these? Yeah? 5 fourths, 5 fourths? Yes. We got this, right? All right. So check this out. So for tonight's home plate, they're going to ask you, identify how many real solutions by graphing the system. So guess where I'm going next? If this one is by graphing, then the next one is by not graphing. That is correct. So in your Cornell notes, write this down, please. Example 2. State the number of real solutions without graphing. Without graphing. And it's the same equation. I'm going to give you the same equation, but now without graphing. I'm going to show you how to find it without graphing. Okay? Here we go. On the right side, I'm going to give you steps. Easy steps to remember, which we've already been using. Step number 1. Tell your neighbor what step number 1 is. Everyone? Yeah, standard form. So clear. There it is. Step number 2. Tell your neighbor your step number 2. Yeah, identify ABC. So you need it in standard form, and then from there you identify your 3 values. And step number 3, I'm going to write it in red. Do the same if you have red. Step number 3, use the, here's a long word, discriminant. Use the discriminant to find real or non-real solutions. You're like, what is the discriminant, Mr. Q? I'll show you. Check this out. First, let's do the first 2 steps. Standard form. Is it in standard form? Yes, we just need to set it equal to 0. There it is. From there, step 2, we need to identify A, B, and C. What did I ask you to do when we got to those the other day? We wrote the standard form underneath. That is ax squared plus bx plus c, because it's easier to see. So what is A, everyone? 2. What is B? 4. And what is C? 1. Okay. Now, imagine that you didn't have the steps and you didn't have the instructions and you have this in front of you. What is this triggering your noodle to do for next? X equals minus B. Don't copy this, just pay attention. Minus B plus minus square root B squared minus 4AC over 2A. That is correct. And I did that on purpose so it can trigger that you need to be thinking about the what? Quadratic formula. But we're not going to use a quadratic formula. We're only going to use part of it. What are we going to use, Mr. Q? We're going to use this part. Look up. In red, B squared minus 4AC. What is that called, everyone? The discriminant. So that means after this, I just write B squared minus 4AC, and I'm going to substitute A, B, and C in there to see if we have real solutions or not. So here we go. What is B? 4, so I write 4 squared minus 4 times A times B. What is A? 2, and C is 1. So this is 4 squared is 16. Negative 4 times 2 is negative 8 times 1. That's negative 8. 16 minus 8 is 8. This one has 2 real solutions. And at this point, some of you are like, how does he know? Well, let me give you the little I guess the table, a little cheat sheet, here it goes. If you use the discriminant b squared minus 4ac to get real solutions, if you end up with a positive number, you're going to have two solutions. If you end up with a negative number, you have non-real solutions. And if you end up with a 0, you end up with one real solution. You're like, okay, let me clarify for you guys. Question: where did I get the discriminant from? From inside the what? The square root, yes? So watch. If I was to end up with a square root with a positive number inside, what do we get at the end? Plus, minus, whatever. That's why we end up with what? Two solutions. How about this one? Square root of a negative. What kind of number is that? Imaginary. That's why it's a non-real. Or in parentheses, I. Imaginary. Does that make sense? Yes? And the last one. What is square root of 0? That means we only get 1. It's not plus, minus. No, there's just 0. And that's pretty much it. So let's look at the process. If I give you a quadratic equation, do you know how to set it in standard form? Identify A, B, and C. And use the discriminant to find out if we get a plus or a minus. Yes? Okay. From 1 to 5, how comfortable are you with these? Yes? 5, 5, 5. All right. And the last one. We still have 3 minutes left. My goodness. Copy this one. Example Q. Last one. Solve by completing the square. Yes. Let's go. Let's go. Anyway. Solve by completing the square. Do we know how to use that process to complete the square? Yes, Mr. Q, that's our favorite. Okay, good. So we're given 2x squared plus 12x minus 32 equals y. Step 1, everyone. Set equal to 0. Okay? So, standard form, 2x squared plus 12x minus 32 equal to 0. Next. Divide by the leading coefficient. What's my leading coefficient? 2. So we end up with x squared plus 12x minus 16 equal to 0. From there, next step. Raymond. Add 16 to both sides. Andrew, next. Oh, it's actually, this is 6, my bad. Sorry, guys. This is 6 and 6. I did that to see if you guys were paying attention. Alright, so this is 6 divided by 2 squared to both sides. 6 divided by 2 squared. Alright, so this is x squared plus 6x plus 9 equal to 16 plus 9, which is 25 equals to all this. Next, Raymond. Square root of the first and the last, so x, 3, sine of the middle, squared equal to 25. Continue, Andrew, next. Square root both sides, so this is x plus 3 equals plus minus 5. Continue, Brooke. Subtract 3 to both sides, x equals negative 3 plus minus 5. And what kind of answers are these, guys? Real solutions. So we're going to ask you on the home plate what kind of solutions you get at the end. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye.